We're revisiting our good old favorite contract here, the abstract JB payout redemption payment terminal 3.1.2, which is the same one we were looking at last time. So last time we talked about the pay function, went into its depths, followed it around line by line. Figured this time it'd be good to talk about at least the most common or basic cases in which payments can be distributed from a treasury. There are three ways to distribute payments from a treasury. They'll all kind of depend on rules configured in your project's funding cycle. So I think today's topic and maybe next week's topic of like project owner configurations may go hand in hand. So we'll leave some assumptions today that we'll revisit kind of the specifics of how it's configured next week. And it should all make sense at the end of it all. But it's probably good to scope down to just one topic per session here. How's that sound?
Yeah, I think that makes sense.
Cool. And we'll get into all the splits logic that Nowonder had requested last week.
Yeah.
Yay. All right. So we're going to hop down. So we've done pay. We're going one of the three ways in which funds can be accessed from a treasury is through redemption of tokens. So last week we saw in pay that you can send funds in and then you can get benefits from that payment in the form of a token or in the form of a custom thing provided by a custom delegate contract. Redeem tokens essentially does the same thing in reverse. So you can put your tokens back in and then get funds back out from the treasury. It's, again, standardized to work with the project tokens that are stored in JB Token Store down here. But again, also has the ability to bring delegates, called redemption delegates in this case, to take on functionality outside of the core protocol that's custom. So in this case, you can imagine paying in like 1 ETH and you get, let's say, 10 project tokens out. In a basic case, and it depends on how the project's funding cycles are configured. In the basic case, you can send those 10 project tokens back in and get the 1 ETH back out. So this is one way to play with accessing the treasury by a community, by token holders. If we scoot down one other function, we get to distributePayoutsOf, which is the other way. Here is what we're going to focus on today. But distributePayoutsOf, it essentially allows anyone, it's a public function, there's no authorization needed, to distribute any funds in the treasury that meet certain criteria out to pre-configured payouts. So if you have, for instance, when you deploy your treasury, if you create an intent to distribute, say, up to 5 ETH to split between several entities, people or other contracts or other Juicebox projects, as funds come in, so if someone chips in 0.01, someone can already start calling distribute, and that 0.01 is going to already start being split according to those percentages across all the pre-programmed splits up until the limit. So in this case, we had set what's called the distribution limit of 5 ETH. And then afterwards, all funds in the treasury can no longer be distributed during this funding cycle. And they remain in the treasury. The verbiage that the protocol uses to denote these funds that are in the treasury in excess of the distribution limit is called overflow. It's funds in your treasury that overflow your current use for them. And so the last way to access funds in the treasury, called useAllowanceOf, a treasury can be programmed with an overflow allowance, which basically gives the project owner permission to spend discretionarily up to a certain amount while those tokens are also accessible to token holders. So if we kind of look at high level these three functions, redeem tokens gives token holders an access to overflowed funds. distributePayoutsOf, it basically sets a distribution limit, which as funds come in, they can be distributed via payouts and they cannot be distributed via, or rather those funds are not considered overflow, so they can't be accessed by token holders yet. Only funds in excess of the distribution limit can be accessed by redeemers. And then also useAllowance gives the project owner access to the overflowed funds as well. If, again, it all depends on how your funding cycles are configured. So these all have to be pre-configured. All of these rules around how funds can be accessed have to be pre-configured in the funding cycle's rules.
Can you go over useAllowanceOf a little bit more? Is that for ERC20s or is it for the project's token?
useAllowanceOf only relates to the Treasuries balance. Let's imagine we have no distributePayoutsOf activated. I'll dive a little bit into the data structure here to give us a little bit of context, and then I'll actually visit this. So when you configure a funding cycle, you're going to pass in values for this data structure. You're going to pass in a terminal, right, which we were just looking at, a terminal, a token, and then we want to pass in a distribution limit, and we want to pass in an overflow allowance. So a distribution limit in this case is the limit of funds that can be paid out from a treasury. And then overflow allowance is a limit of funds that can be accessed discretionarily by the project owner. So just for context, let's assume distribution limit is 0. So let's just isolate overflow allowance here briefly. And I'll go back here. So in the case where distributePayoutsOf is not callable because there's no distribution limit, then any funds that come into the treasury are considered overflow and are accessible by token holders if redemptions are configured, and by project owner if overflow allowance, if this allowance is configured. So let's say the project owner has specified an allowance of 1 ETH. The first ETH that comes in, if the project owner wishes to access it and distribute it, it can call useAllowanceOf up to that 1 ETH. You'll see here that this is a permissioned call. Only the project owner or a specified operator can call it. And then you'll specify the beneficiary. So who gets that amount that's being distributed as part of overflow. Otherwise, token holders can also access the funds at the same time. So it's like who wants to access it first, right? So you have a sum of money in the treasury that both can access. The project owner can only access it via a direct call. So it's not like a publicly pre-scheduled distribution. It's discretionary spending by the project owner. If you add the distributePayoutsOf, the distribution limit, any funds that come in up to that limit will first be used here, which is public, so anyone can at any time go and call it and distribute anything that's in the treasury up to that limit out. So it's not permissioned, it's pre-programmed, like where those destinations are. And meanwhile, those funds are not accessible by redemptions or by overflow allowance.
And those destinations are basically the project's, the funding cycle splits?
Yes, exactly. We'll get into that once we dive in here. So this is kind of just overview context. And if we have time, let's definitely dive into these two functions. Overflow allowance is pretty simple. Redemptions is pretty involved. Distribute payouts is decently involved. A lot of the network's operations get handled in distribute payouts since you kind of can call it in batch. Payments can come in. Those are pretty cheap. They accumulate. And then to actually allocate all those payments that come in, you usually project owners have predetermined where funds can go as they accumulate. A lot of that kind of gas operations happens in here. But let's dive in. We'll just go directly into this internal function. There's nothing to do otherwise. We're going to be working from here up. We'll go through line by line.
Oh, I have a quick question. The 312 terminals, do they have any different like setup configuration?
312, the only thing it does is it fixes a calculation if the funding cycle has the hold fees flag flipped on. We'll see here where that comes into play. This hasn't applied to any project because most projects don't have that flag flipped on, but it's just a nuanced thing. Like the terminals before weren't making projects entirely whole when they had that flag on.
Right. Okay.
Cool. So the first thing we're going to do once we call distributeOf is we're going to go back to the store. Remember last time we went into the store to actually save and store information about balances and kind of do a few more kind of data-oriented calculations. The first thing we're going to do here is go back to the store and record the distribution for this intent to distribute payouts. And in response, we're going to be getting the project's current funding cycle, so the current rules that apply for the project, and this amount of how many funds were distributed. So I think it's going to help to right away go into this and check out recordDistributionFor. So I'm going to go in, I'm going to go to the store, then here. So here's where some of that data gets thought through. So first thing we're going to do here is get a reference to the funding cycle, which is a set of rules that currently apply for the project. We want the current funding cycle, obviously. We want to check in the funding cycle to see if distributions are paused. So this is a flag that project owners can set ahead of time to label a distribution limit, but not have it executable. So distribution limits paused, then go ahead and revert. Now we want to figure out what is the new used distribution limit of the project for this particular payment terminal. We're going to do that by getting the current used distribution limit of this payment terminal, which is the one calling this function for this project in this funding cycle. So we explicitly only want to know how many funds have been already distributed for this project in this payment terminal during this funding cycle. And then we want to add the amount that's being distributed here to kind of get a reference to the new amount. We're not storing it yet, we're just getting a reference. Then we're going to go to what's called here the fund access constraints store. Very simple contract. It just stores the data structure that I had shown earlier that just has those few properties. So we just want to get a reference here. What is the current distribution limit of this project for this particular payment terminal that distribute's being called for in this funding cycle? And we want to get the currency that distribution limit is measured in, because you can measure the distribution limit in a currency other than what's been paid in. For example, JuiceboxDAO measures theirs in US dollars, but the currency that the actual funds are stored at is ETH. So we want to get the distribution limit and the currency. Notice here already that you can have many different distribution limits for different terminals. So I think a question last week was, why might a project have multiple terminals? And what happens if they do? Well, they can schedule different distribution limits from each if they want to get fancy with some operation, or if there's some schema in the future that folks want to build.
So multiple terminals?
Yeah, like if you're a project and you have an ETH payment terminal and a DAI payment terminal and like a shitcoin payment terminal, you can have like, oh, we have payouts scheduled from the ETH one, but none from the DAI one and none from the shitcoin one, right? Or you can have some pre-scheduled for a funding cycle from each of those. That's kind of up to you.
And so JB configures its payouts in US dollar denominations? I never noticed that.
It does, yeah. So so as the ETH price fluctuates, just whenever distribute is called, so whenever someone actually runs this transaction we're looking at, it's going to take the price of the treasury asset and then compare it to the distribution limit currency and then normalize it. So we're kind of always dollar cost averaging in a way via kind of payouts and the work going on.
Cool.
Sweet. So once we have access to this, then we're going to do a quick check to see if the limit has been reached. So if the new used distribution limit is greater than the distribution limit, or if there's no distribution limit, then go ahead and revert. So at this point on, we assume that the distribution limit is good to go, that we can actually move forward with the operation.
They also say, like in programming, the hardest thing is naming, like naming files or naming variables.
Yeah, absolutely. It's definitely hard, and I feel like I and probably many others wish we had a protocol schema where we can just change names at any time to kind of go with the latest conviction of like what do we call these things. From the protocol's perspective, we went very literally with the distribution limit phrasing.
The names just end up being so long sometimes.
They do. Yeah.
It drives me crazy. Yeah.
Yeah. That's why I think videos like this sometimes help, because like I can just enunciate it. You don't have to read this long camel case word, which, there's arguments for snake case over camel case for longer names, but
What is snake case versus camel case? I actually don't know the difference.
I think snake is underscore and then lowercase, a new underscore, a lowercase used underscore distribution. So you can kind of like see the word better.
And camel case just doesn't.
Camel case uses caps. So no cap to start, and then caps for each word, each new
Oh,
word. Yeah, like funding cycle, we go back and forth a lot. Like it has like a cyclic pattern and it has funding parameters, but really it's a set of rules. So could you call it like rules? I don't know. Ultimately, just kind of in explaining it, they all start to be used together and mental models arise, but it's really hard for newcomers. And also hard for web clients who are trying to express something to users, but the protocol says it a bit differently. But alas, probably not worth a v4 to like change it, because that'll almost surely mean there will be a v5 that changes it to something else shortly thereafter.
Yeah, true.
Tokens and money around, and all of a sudden you're in a tangled web of finance, and that's no good. Okay, cool. So we have checked the limits. Now we're going to check that the currency being paid in, so the terminal that's doing this distributing is the same as the distribution limit currency, to match up intents, right? If they match, great. Otherwise, we're going to throw currency mismatch. Now we're going to get the currency of the balance. So this particular store assumes that whoever's calling it is a single token payment terminal, which has a single currency. So in this case, we were looking at a generic abstract terminal here, which can be ETH or ERC20 or whatever. Either way, we want to get whatever that currency is of the actual asset sitting in the treasury, because like I said earlier, we're going to want to compare the balance currency to this distribution limit currency and normalize. And here's where we do that normalization. So if the currencies match, then we can just return amount. Otherwise, we want to go to the prices store and get the price, the current price that normalizes these two currencies. And we want to divide the amount by that. So to kind of readjust what that distributed amount is. Because ultimately, when we return to the terminal, all it's going to care about is the distributed amount, which is the currency it deals with. Once we have that distributed amount, we're going to do a quick check to make sure that this project has balance, like has enough balance in general to fulfill this request. Despite the limit being checked up here, maybe the project doesn't even have enough funds, right? So if the limit is 5 ETH and it only has 1 ETH in, you can't distribute 2 ETH in that case, right? Because you only have 1 ETH. So go ahead and check and revert in this case. Now we're going to save the thing we calculated earlier, the new used distribution limit of, into the used distribution limit of storage slot. So now we're actually going to do a storage operation. And then lastly, we're going to decrement the balance that this project has. So if it had 1 ETH and it's distributing 1 ETH out of a 5 ETH distribution limit, it now will have 0 in the balance, and its used distribution will be 1. So next time it gets an ETH, it'll increment this. So now used distribution will be 2. Balance will again be 0. So you can kind of keep doing this until the used distribution is totally kind of used. And then this operation will no longer be possible, and then balance can start accumulating. Does that kind of make sense?
Yeah.
Cool.
Pretty straightforward. Yeah.
Yeah, pretty straightforward. A lot of operations, but tries to kind of cleanly solve the problems at hand.
Yeah, it's the usual Solidity accounting function.
Yep. So back to where we called this from. So at the end of the day, we should have distributed amount in terms of the currency of this payment terminal and then the funding cycle. So first thing we're going to do is check if the distributed amount is less than what we expected. The distributePayoutsOf function takes in an expectation because the currencies might be different from one another. So we want to make sure that after the oracle runs and normalizes the price, that it in fact matches at least some amount that we expected to come out. We want to then get the project owner, get a reference to the current owner of the project. This is important because what's going to happen next, and this is kind of the most complex part of this function from a kind of algorithmic perspective, is actually taking a fee from this distributed amount. So here's where the JBX fee comes into play. Remind you that the JBX fee is taken on funds distributed out of a treasury only to distributions that don't go to another Juicebox project. So if the funds being distributed from a project stay in this contract but are just reallocated to a different project, then there's no fee. But if the funds are being taken out of the protocol, then we charge the protocol fee. That fee gets piped down to JuiceboxDAO's project via a pay function, and then in return, JBX gets issued. It gets issued for the project owner. So whichever project is distributing this fee, that project's owner will end up with the JBX. So here we're just getting a project's owner, a reference to that address that will be the beneficiary of that fee JBX. Next, we'll keep a reference to the fee that we're going to be calculating, and then some more stack too deep prevention with scoping some of this properties into this little block, which is the majority of the rest of the function. But here's where the fee magic happens. So here I'll go through it line by line, probably repeat it a few times because it does get.
Can I ask you something about scoping real quick before you get into it?
Sure.
So I thought the idea was the scope variables, like you kind of don't need anything after the fact. So you can I guess you can perform a calculation in here, but then how do you, if it's blocked, can you actually assign things outside of it? Like you have to be able to, right?
Yeah,
Okay.
here's where I would assign. So feeTaken here, you'll notice is the one thing I need to use outside of the block. And so everything defined in the block here is in scope as if it were a different function, kind of. So I can introduce these variables. And by the time I get out of here, the compiler knows that I can discard anything introduced in this block kind of out.
How does that work? Does Solidity have does the compiler think of it as a separate stack?
Yeah, I'm not too sure, but I think it's as if you were to have called a different function with this calculation, and then the return variable is basically this. So you can kind of think of this as an internal function that could have been called, and it's a different, and then kind of a different thing gets pushed into memory that has references to where you left off and where you jumped to, and then once that jump is done, it'll go back. I don't really know the specifics of how that works. I just know broad strokes, kind of stack management. This is the way to get it to actually run. But
yeah, those stack too deep errors.
Yeah,
I remember my first.
Oof, yeah. I mean, it's a beautiful thing, right? I love programming with high intent, where you have to really think critically about everything that you're using and what you're storing, and how to find creativity therein. Because oftentimes those constraints actually lead to some eureka moments of refactors and resimplifications. So I enjoy it, but that's because I feel like I'm also a patient, stubborn, persistent person who doesn't mind spending days on end trying to
but it's really such a scary thing. The compiler is not Solci's not always explicit about what things mean sometimes. So you're oh my god, what's the stack?
That's the worst. You at least want to know what's going on. Yeah. And I say this with a grain of salt because once it actually happens, I wish it never happened and that I can actually just do what I'm trying to do. So I don't wish it upon anybody, but it is nice to design interesting systems under tight constraints.
Yeah, for sure.
Okay, so what we're going to do here. First, so the fee is stored at the contract level. So there's a global fee in this terminal that's settable by the JuiceboxDAO up to 5%. Get a reference to the current fee and keep it around in memory. There's also a fee discount potential. So rather, this contract here also has reference to a fee gauge, which is the contract that can be introduced by JuiceboxDAO that can calculate a particular fee discount given current context. It does not currently use one, but it has the option to use one in the future if it needs to use some kind of fee discounting mechanism or wants to route fees. A hypothetical example is kind of like Curve does, rewards gauging, where stakers can point their vote to a particular pool to receive rewards. Or you can theoretically do JBX stakers can allocate their stake towards removing or mitigating fees from certain projects. It can be anything, but there's an option for a fee discount is kind of the point of this little block. And to get that, we'll go down here and just see quickly that it's just going in. Well, I guess first it's going to check if the protocol project, so if JuiceboxDAO, that's supposed to be taking the fee, If it doesn't have a terminal that accepts the token that's being distributed, then go ahead and set the fee discount to 100%. You don't have to pay a fee. For instance, if you're running a DAI terminal, but JuiceboxDAO does not yet have a DAI terminal, you can't pay a fee. Like JuiceboxDAO has nowhere to accept that fee. So there's no fee. That's kind of the first case here. So 100% discount. And then otherwise, we have a fee gauge kind of check here, right? So if one exists, then go and get the current discount. Otherwise, return 0. So pretty kind of straightforward there.
So currently, like you could deploy an ERC20 terminal and just not pay Juicebox fees because Juicebox does not have the same terminal.
Totally. Or you can deploy another ETH terminal that just removes all this fee logic and run it, right? But then it really depends on clients to recognize that new terminal, right, in its processes. So like JBM could, for instance, like fork this entire stack and route fees to like a different treasury. And then it really depends on like, okay, but where to do, like what else depends on that. And so you could end up with a very fractional ecosystem of like everyone's using different terminals and they don't talk to one another.
Mm-hmm.
The intended outcome is if it's all pointing to one place and it's well used, then everyone wants to take part in that ecosystem.
Okay, I guess I really never understood like the purpose of nominally calling it a terminal, but now that makes a lot of sense.
Yeah, there
Cool.
can be any number of these things. Like, yeah, and the point being, like, even as developers of this protocol, like we don't want to lock ourselves into a future that we don't consent to, right? Like we can't really get organizationally taken over if it's just a matter of permissionlessly deploying another terminal that does things differently and convincing the people that matter that like, hey, we should go over here. But it's designed so that anyone can do that, just in case, like independent of who you think is abusing of power or relationships, there's still a clean way out.
Yeah. Okay.
Sweet. So we get that fee discount. Now comes the really fun part. Here's where we're going to actually do the distribution to the payout splits. And the result of this distribution, we want to have access to two things here. We want to have access to how much is left after this payout has been distributed. So you can imagine a payout splits kind of only taking like a few percentage of the total into account, but leaving the rest there. So for instance, like you can say 1 ETH distribution limit, half of which goes to Matthew, right? And the other half goes to the project owner. Anything that's left after you call distributePayoutsOf gets sent to the project owner. We want to keep a reference to what's left after splits have been fulfilled. And then we also want to keep a reference to feeEligibleDistributionAmount. This is because splits, some of those may go to other Juicebox projects, and we don't want to charge fees if you're just sending funds between projects on Juicebox.
I have a quick question about splits.
Dive in.
Okay, the grouping, I'm a bit confused on groups. I actually don't understand it at all.
That's a great question. I'm going to touch on that in just a sec.
Okay, sure.
But yes, we're going to spend like the second half of this session just in this function here. But I think it's worth, if we can skim over the general what's going on here, it's probably worth finishing this and then going all in on like what happens in the splits world.
Okay, cool.
All right, so let's assume we have the leftover and we have the amount that's eligible for fees. We want to then check, it's reading this in line, double checking. Yeah, so if the fee discount isn't 100%, meaning there's still some amount of fees that should be taken, we're going to go ahead and add the leftover distribution amount to the fee eligible distribution amount because those funds are going to the project owner. They're leaving the protocol. So we want to just go ahead and increment here. And then if this fee exists, if there is some amount that is eligible for having a fee taken, we want to actually take that fee. Here's where we actually call the pay function of JuiceboxDAO. We want to pass in the amount being the fee eligible distribution amount and the feePercent, the project owner, which is going to get the JBX, the fee discount, everything you need to know. And the result is going to be the fee taken, so the amount of the fee that was taken. And then lastly, we're going to send the funds to the project owner. So if there was a leftover distribution amount, then we want to net is, yeah, this gets returned from the whole thing. So once the distributePayoutsOf function returns, it's going to give whoever called it a reference to how much funds went to the project owner is ultimately what it's going to communicate. So we're going to just update that calculation so the return value is correct. So if I call this and the project owner got 1 ETH minus the fee, so 0.97 ETH, then that's what's going to get returned. And then we're actually going to call the transfer_from function, which is, again, one of those virtual functions that gets implemented differently depending on if the implementer of this abstract contract is an ETH payment terminal or an ERC payment terminal or something else. So this is the completion of sending the payout. And if this all makes sense, then I'm going to dive into this function, which will be a little bit of a doozy, but it's good.
One thing, where did you say the fee discount? How is the fee discount set or determined?
The fee discount it comes from that function with the fee gauge, the current fee discount, which is 100% if JuiceboxDAO doesn't have the payment terminal of whatever token's being paid in. Yeah.
Cool.
All right, so let's dive into distributeToPayoutSplitsOf. This one is a big for loop. First thing we're going to do is do the splits group of. So I'm going to do a quick detour and explain how that's set. Although this is going to be one of those topics similar to setting distribution limits that's going to be more in-depth next session or whenever we do the reconfigure deep dive. But essentially, a project can store splits relative to any number of groups and therein any number of domains. These are two abstract terms that are just meant to delineate namespaces. But in this context, you'll notice that domain here.
That's basically the project, right?
Domain here is the funding cycle configuration, which makes sense because we want the splits that are programmed for the current funding cycle. Because you can program different splits for the current funding cycle and then the next funding cycle. Those are two different domains where you can have different splits stored relative to those things. So if distribute gets called, next funding cycle, domain will automatically get a reference to whatever splits are stored for that funding cycle. And then group is a very simple namespace. Currently, people can roll whatever functionality they want, but there's ETH payouts as a group, and there's reserved tokens as a group. Those are both splits in the same sense. They're both stored in split store. One of them, projects can configure group 1 to be used by this payment terminal here to denote ETH payouts. Reserved tokens can be used to denote splits of reserved project tokens, but they're splits nonetheless. They're just stored relative to a different splits group.
So if you select reserved tokens, would that mean that the payout comes from, it's not going to come from a terminal, right?
Totally different use case. Yeah. It's a totally different use case, actually. So I'm going to go into a project here, just for example. So you have Juicebox project has payout splits, right, which is what we're looking at here in the contract. And then it also has reserved token splits. So as a pay, remember when we did the pay function, as a payment comes in, a project can have a reserved rate. If it does, it reserves half of the tokens that get issued. That as a result of that payment, it reserves that to be split amongst a group of recipients.
Right.
So reserve tokens is here, and this distribution does not happen in the function we're looking at. This happens in the controller. So if you want to look at that, go to.
Right. Yeah, that's what I was wondering, because when I was writing the split allocator, it was I needed to differentiate between it coming from a payment terminal or the controller, depending on if it were the project's reserve tokens or not.
Yeah, so the controller distribute reserve tokens of, here's where you'll get a reference to that splits group.
Cool.
Yeah. And so the cool thing is, if you have multiple payment terminals, like we were talking about earlier, let's say I have an ETH, a DAI, and a shitcoin payment terminal, I can have different distribution limits for each of those, and I can also have different splits for each of those. Those would just be a different group, but all within the same funding cycle, right? So then it's just a matter of occupying the namespaces in a way that's well known. If I deploy a payment terminal, like a DAI payment terminal that uses group 3, for instance, when I configure my funding cycle with that terminal, I should know that I need to save splits relative to group 3. And then I have to, as a project owner, be aware of conflicts. I say project owner, but it's mostly that responsibility is mostly passed on to web clients or folks helping users interact with the protocol. But in the blockchain world, we assume that that's an end user, even though now I think the space is rightfully obsessed with figuring out how to build middle layers between end users and contracts.
So did you say there can be conflicts between groupings?
Rather, if I deploy a payment terminal that looks for splits in group 3, and you deploy a payment terminal that looks for splits in group 3, the project can only set splits for group 3 for a funding cycle once. So what we're saying in that case is that we know that we exist, and if a project wants to use both of these, they're going to have to set the same splits for both of these pieces of functionality. So there has to be some loose coordination if we want to make sure that these things can be used with different sets of splits.
Okay, gotcha.
Yeah. Again, once we dive deep in protocol world like this, we're really far away from what we see day to day with JuiceboxDAO clients. We're in the world of like abstractions that are meant to facilitate arbitrary number of things efficiently into the future, because we don't want to be in the business of continuously revisiting this. We want to write it once and have it work for arbitrarily different applications on the surface over time, which we don't really know what those will be. Really depends on what we find is most useful for people. So now comes the fun bit. So we have a reference to the splits, and that's all we need now. We have the reference to the splits, and we have the funds inside this contract, and all of our accounting has been updated. So now we just have to send out the money. We're going to loop through the splits, and we're going to do a case checking. So a splits structure has a few different things in it. Some of it's overloaded, meaning if one thing is set, then something else means something different than if it's not set. So I'm going to go through this slowly and treat these in 3 basic cases. The first basic case is you're paying a address, right? This is standard ETH stuff. You're just paying an address. You don't care about anything else. If you're just paying an address, all you need to do is set the beneficiary. The beneficiary is the address you're paying. You must set project ID to 0. Percent is going to be what percent of the total you're sending to the split. Prefer add to balance doesn't matter. PreferClaimed, it doesn't matter. Allocator set to the 0 address here, and then locked until it doesn't matter relative to the function we're talking about. We'll visit this in the reconfiguration session. So if you're just the beneficiary or the ETH address, just set beneficiary 0 and the 0 address here. If you're paying another Juicebox project, then you're going to set the project ID as the project you're trying to pay. The beneficiary then becomes the recipient of the tokens for that project ID. So you can set these splits such that they pay other projects, and then whatever reciprocal benefits that are received will be received by this beneficiary. Add to balance is a flag indicating, do you want to pay the project ID via the pay function or the add to balance function, which we visited last week. The add to balance function is very vanilla, it doesn't do anything, it just dumps funds in Treasury. Maybe that's what you want, in which case you can specify it here, in which case also beneficiary won't matter, because beneficiary only matters in the pay case. And then preferClaimed is again one of those flags in the pay function that specifies if the tokens that result should be claimed automatically or if they should be stored in the JB tokens store, which would decrease the cost here slightly.
And so a claim would do what with the tokens in relation to the project that's being paid?
So the preferred claim flag is like, do you want the balance of these tokens to just be stored in the JB token store to later be claimed into ERC20s if one exists for the project? Or as part of this operation, do you already want to claim the ERC20 and send it to the beneficiary?
Okay.
So remember last week, one of the pay function flags was preferClaimed tokens, which would increase gas slightly, but that would kind of move the ERC20 directly. Otherwise, the balance accumulates in JB token store, and then the owner of those tokens can in batch pull them out into ERC20s at any time later.
Okay, so that would pretty much depend on if the project is like used to that sort of operation, like pulling out of the token store, or if they just aren't really, and you can just send this flag. It's like, hey, now you don't have to worry about it. Yeah.
Totally. Yeah. I mean, usually this is false. We want to just kind of keep gas as cheap as possible. And then if folks are curious, hey, why don't I see these tokens in my wallet? Well, it's like, hey, you have to go and claim them into your wallet. Otherwise, they just kind of live in this contract down here. Like your balance kind of lives here.
Yeah.
The last thing you could do, so we have the case where the first case was pay an address, second case was pay a Juicebox project. The last case is pay a split allocator, which is the custom hook. Similar to pay delegates and redemption delegates, split allocators is a custom contract you can bring that just has one function called allocate. And so this contract here, if you implement an allocate function, you can receive payments from splits and do special things in line to the distribute payouts call. So back to the loop. We have a reference to all these splits. Now we are going to loop, and we're going to basically do what I just said out loud in code form. First thing we're going to do is get the payout amount, which is a function of the amount in the split percent. So get a reference to how much we want to send to the split. And then we're going to actually do the payout to the split. So we'll hop over here in a sec. This is going to actually execute that case, like if there's an allocator, send there. Otherwise, if there's a project ID, send there. Otherwise, send to the beneficiary address directly. And then we get a reference to the net payout amount. And then we want to just do some quick arithmetic here just to increment the values that we need, the fee eligible distribution amount, decrement the percents that we already used. So really everything that's left here is going to be in this distribute to payout split function. And we will do what we expected here. So if it's a split, if we do have a split allocator, then we're going to allocate to it, which is this whole chunk here. It's kind of a big chunk because we first want to check if we are kind of taking fees along the way here. This terminal also accommodates a mapping of feeless addresses that JuiceboxDAO can set. So JuiceboxDAO can treat certain allocators that it chooses as feeless, meaning fees will not get taken when allocated to those addresses. So it's going to just check to make sure that this is how much should I actually be sending here? Should I take a fee? Then it's going to package up the data to send to the split allocator so that it has information on what's going on, like what's being paid, how many decimals are in that number, what's the split group, give me the full splits information. Then it's going to do a little bit of error check-in just to make sure that once you do call allocate, if it reverts for some reason, the other payouts can still be handled. So what we don't want is for anyone to be able to cause some failure in this payout chain and then no one can get paid. Instead, if any of the splits fail, what we're instead going to do is revert and just add to this project's balance as if this one split didn't happen, but everything else still does. So you kind of occupy a little bit of code lineage here with just error reversion and handling. And if no errors, then all it really gets called is this, right? You just allocate.
Yeah, it's weird to see this type of like async code, like the try and catch block in Solidity.
Definitely, yeah.
It's always a little surprising to see. I'm like, oh, something's happening.
Yeah, and we learned the hard way. I mean, this is something that wasn't in, I think, V3. We added in v3.1, I believe, because I think I had asked JuiceboxDAO to receive payouts into another treasury, and I also had payments paused in that treasury, or rather, there was something up with it. I don't know if it was paused or something else, but whenever that cycle came around and folks tried to distribute payouts, which was everything else JuiceboxDAO had committed to, it couldn't because I had fucked up something in my treasury, right? And so now no one could get paid. It was like this is worth versioning terminals for. We need to do better error handling here to make this a resilient protocol. Otherwise, likely not worth adding a non-ETH address destinations that can, on their own terms, block everyone else's allocation.
Yeah, it's like a denial of service in a way.
Yeah, for sure. So the case here is also pretty straightforward. So else if, meaning if no allocator is specified, but a project ID is specified, then what we're going to do is go to the directory and get the primary terminal of this project ID. So where should we pay? Get that payment terminal. If there is no payment terminal, do some of that error handling. The project should have a payment terminal if it wants to get paid. Do some of that fee checking. A payment terminal in this case could also be feeless. JuiceboxDAO essentially has control over its fee space, right? So 5% fee, and there's mechanisms to allow it to give permissions therein, but it normally chooses not to. I imagine it would take a heroic governance effort to convince it. But there are some cases, like when migrating from macro version to macro version that has a different ecosystem altogether that you want to be able to move funds without incurring fees. And then we want to do this a quick pivot. If prefer add to balance, else pay. That's as we expect. Everything else is just more of that reversion catching. And then lastly, we are going to just transfer. If neither of those two cases were met, then we just want to transfer to the beneficiary. And importantly, if there's no beneficiary, so if you didn't specify either an allocator, a project ID, or a beneficiary, then the intent is pay whoever called this function, which basically means this function can get expensive, right? Like you're doing a lot of work here, and maybe a whole lot of work. If there's arbitrary things happening in split allocators and you're paying a lot of projects that have pay delegates and all kinds of stuff. So you might want to program in an incentive to split some to whoever calls the function. And that's possible by sending no address here. So maybe won't want to chip off, a tiny amount to whoever calls the function, which is a public function.
So no beneficiary is set. Does that also mean that no project ID was specified, or
right? Yeah.
am I thinking about this wrong?
This is also in the case where no project ID is specified.
Okay.
So we've already else ifed the project ID.
Okay, so if I'm ever wondering like how to program my split, this is where I would want to look. Like,
Yeah,
because I feel like I'll forget some of this and I'll have to reference it. But yeah,
this is the meat and potatoes. Yeah, but even if you're paying a project, if you want to set your beneficiary, you can set the beneficiary of the token of paying that project explicitly, or you could also give the message sender those benefits, right? Again, this is just a why not thing more so than this has an explicit like meaning in the protocol. But if you leave all these fields empty, instead of reverting because I don't know what to do, I'd rather just say add a bit of functionality. Like you can send it to whoever's calling this function.
I guess that's part. Like, who would it be? I guess that's what I'm a bit confused on. Just anybody.
Yeah. So let's say you want to. I think Matthew does quite a bit of calling the pay function. So you probably get a sense of the tax that you pay, which I think JuiceboxDAO maybe even does some refunds there. I forget the rules it's approved. But if you want to have it more automated, you could either program a little bit of the payout to go to whoever called the function to create some maybe even MEV incentive to just call it automatically.
Oh yeah, cool. Yeah.
Or you can have some pay function. So you're not going to get ETH, but we're going to pay a little bit to this other project and you'll get whatever tokens that they issue, which might also be incentive for the message sender to actually call, or for MEV to call it automatically.
How would that be set up? Is there a way, like, how would you set up the reward for calling the payout?
You would just not add an allocator. So you want to end up in this case here, right? So you don't want to add an allocator. You want to bypass this. So you do not want an allocator. You also do not want a project ID unless you're doing the beneficiary case. And if you don't have a project ID, then you're going to end up in this little block, and then you're just going to transfer from. And you do not want a beneficiary if you want to send it to the message sender, which is the address that's triggering this distribute call. So if everything is empty, essentially, in the splits object, you're going to end up, the amount of the split is going to go to the message sender.
Weird. Okay. So basically a project would also just not have anything configured. I guess that's what I'm confused on still.
Like imagine a project like a YOLO Shiba Pepe Elon 69 token that has a 1 ETH distribution limit, and it has one split, and that one split has an object that has 100%, but everything else is 0. So that
Okay.
means as funds come into this treasury, whoever calls distribute gets it. So it's kind of a pointless treasury, you could say, but that's what would happen, right?
If you had one split that was configured like that and another split with actual payouts, then that's kind of how you would configure an MEV reward for
Exactly. Yeah.
the payout incentive. Okay.
So leave a split that has like 0.5%, right, can be empty, and then the rest can be functional.
Yeah.
So then that 0.5% would still run and would get sent out the amount.
Okay, really cool. Yeah.
Cool. That's basically the extent of the whole function. So once you've wrapped your head around this loop, you just realize that any splits that you're adding will incur this loop. So the more splits you add, the more gas intensive your distribute call is. But oftentimes, the more splits you add, the bigger the treasury is, the more responsibilities you have. So it all kind of evens out. But it's definitely worth noting that it gets looped for each split. But they're pretty powerful objects. You can roll all kinds of functionality in splits allocators and do a lot by default just by routing to projects and to addresses. And the take fee function here is where we have a little bit. I know we touched on the hold fees when we talked about adding to balances last time in the other session. Take fee, which is what we call in this function as we're distributing, is going to check if the hold fees flag is on, and if so, it's going to hold some of those fees in a mapping in a storage locally in this contract. Otherwise, it's going to process the fee, which is actually going to go and get the terminal of the beneficiary project ID, which is JuiceboxDAO's, and call its pay function. Again, if JuiceboxDAO's pay terminal is broken for some reason, then you can still pay out from your project. Pay is designed to, or rather, the distribute function is designed to work no matter its dependencies. You'll just get your money back if any of your dependencies do not work.
Cool.
And that is that. That is the heftiest of Juicebox pieces of functionality, and it's where a lot of the magic happens. But the cool part about Juicebox is that it does bundle a lot of functionality into these predictable cyclic transactions that can be called by anybody. So you don't need permission. You don't need to wait on the project owner to get paid. You don't need any of this stuff. You just need to have it configured, and then someone willing to send that transaction, preferably when gas is a little cheaper. Another nice thing about this is you can wait. There's not a lot of time pressure apart from the resolution of that oracle that determines currencies. That might be an incentive to call it sooner rather than later if the prices are in your favor. Like imagine you're getting a payout. So there's two adversarial parties here, right? There's the token holders who have access to the treasury in excess of what's being paid out. And then there's payout recipients, which have access to the payout. So if the price is leaning one way, maybe the community has slightly more incentive to call pay. And if the price is leaning another way, maybe the payout recipient has slightly more incentive to call pay. Either way, it's public, and so it should kind of work itself out according to like who most urgently wants this function to resolve soonest. And the idea is someone needs to call it during the funding cycle. If it doesn't get called during the funding cycle, that amount gets forfeited, right? It doesn't roll over to the next funding cycle. The next funding cycle has its own set of rules. And so what's important is someone needs to call this during a funding cycle to actually fulfill its commitments.
Yeah.
But the whole thing is designed such that someone should be incentivized to, either through this MEV kind of relic here, or just through the fact that they're getting paid, so it's worth calling, or the price is leaning in one direction, so it's worth calling.
Yeah, you might take like a bot calling the payout function kind of takes away the game of chicken that the payout recipients are playing with the token holders. Yeah.
Yeah. Otherwise, you wait till a Saturday night when everyone is allegedly off the computer or on a different tab playing D&D or whatever, and gas is cheap, and call it done.
Do you think it's worth making the split that would pay somebody out, do you think it's worth like maybe incentivizing that? Like maybe standardizing that as like, hey, like this is a flag you can enable that rewards whoever pays or whoever calls the payout.
I think it's dope. I also think it's dope if clients like Juicebox Money and the developers who build it, like Peel, as folks are configuring projects on JBM, I think it makes a lot of sense for Peel to add a split into their split dynamic. That's a 2.5% fee into the Peel treasury. So like clients can use the same mechanic to augment the JBX fee, which is baked into the protocol, with a client fee. Especially nice if that token that gets created as a result also has network effects. So this is a way that it's kind of open-ended in kind of incentivizing clients to build ways to program these tools, to incentivize people to trigger these functions. A lot of underexplored things. Obviously, Juicebox is very complex. There's a lot of levers to play with. The good news is none of it really gets in your way if you're not using them. They're just kind of there as niceties if you ever want to do something. You don't have to rewrite the protocol or do a big version change. But maybe it'd be nice to introduce these ideas in the form of a JBDAO proposal to actually warm up the audience. Because I think a lot of people don't look at the code, obviously, or even watch these videos to actually get a sense of what's entirely possible. And the documentation is also thick. So a lot of nuance gets lost.
Yeah.
But over time, I think ideas shape up that pin down a few of these pieces of functionality specifically and exploit them, right, to create something like powerful and usable. And that's when some of these ideas really come out.
Yeah, this is one crevice where it's like, oh, wait, that's actually super cool. And it just, there's all these corners. And eventually cool things will crop up like that.
Totally. Thanks all for listening and for the great questions. These sessions are amazing because of No Wonder. I just want a big shout out to No Wonder, who's been doing these real-time feedback and questions. I think it helps me focus on certain aspects and hopefully helps the audience relate to some of these aspects of the protocol. I think this is becoming a fun little duo in these sessions, and big thanks to Matthew and Briley for helping with the editing and production of these videos once they're done.
Yeah, thanks for having me.
There's obviously more odds and ends of the protocol. Next time, I think we'll leave maybe overflow allowance and redemption access to the treasuries for next time, and then eventually get to project owner reconfiguring rules. And I think at that point, we'll have our bases covered. That's the extent of what the protocol does. But in the meantime, we'll do these one at a time.
Awesome. Well, thank you so much, Jango. Really appreciate it.